Welcome to Brain Vision.
Let us consider the velocity of car in horizontal direction. So we will write VA is equals to 18,000 divided by 3600 meter per second I. So it will come out to be 5I meter per second. Similarly, the acceleration of car in horizontal direction will be equals to 3I meter per second square. And consider the angular rate of Ferris wheel. So this is angular rate of Ferris wheel is equals to 3 multiplied by 2 pi divided by 60. So it will come out to be 0.314 radian per second. We can write it as omega also. Now let us calculate the velocity of the observer in the Ferris wheel. So velocity of observer in Ferris wheel will be r omega. So let us put this. R is given as 9 meter multiplied by omega is 0.314 radian per second. So it will come out to be 2.826 meter per second. Now let us express the velocity of the observer in terms of vector. So we can write velocity of observer in terms of vector v. It will be 2.826 cos 45i minus sin 45j meter per second, or we will get velocity of observer, relative velocity of the observer with respect observer will be equals to 2I minus 2j meter per second. Now let us calculate the relative velocity of observer with respect to car. So we will write velocity of observer with respect to car, that is VAB, is equals to VA minus VB. So let us put the values here. So VA is 5I minus VB is 2I minus 2j. So we will get a values of 3I plus 2j. 3I plus 2j. So this is the velocity of car A relative to observer B. Velocity of car A relative to observer B. Velocity of car A relative to observer B. Now let us express the acceleration of observer in terms of vector. So we will write AB is equals to omega square r cos 45y minus sin 45j meter per second square. So let us put the value of omega. R is 9 multiplied by omega is 0.314 square cos 45 I minus sin 45 j. So this will come out to be minus 0.627 I plus minus 0.627 j. This is in meter per second square. So now let us calculate the relative acceleration of observer with respect to car. So we will write acceleration of observer with respect to car A is equals to AA minus AB. So let us put the value of AA, that is 3I, minus the value of AB is minus 0.627 I minus 0.627 j. So after calculation, after solving this, we will get this as 3.627 I this is minus plus 0.627 j. This is the relative acceleration of car A, and this is the acceleration of car A relative to the observer B. So this is acceleration of car A relative to observer B.